Welcome, stargazers and history enthusiasts. Today, we're delving into the annals of science to uncover a tale often overlooked. Prepare to journey back in time to an era known as the Islamic Golden Age. This period witnessed an explosion of knowledge and discovery. We'll explore the lives and legacies of brilliant minds like Jabir bin Hayyan, Al-Bayrouny, and many more. Get ready to be amazed by their groundbreaking discoveries in mineralogy, geology, and beyond. Imagine a time when Europe was shrouded in the Dark Ages. Across the Mediterranean, a vibrant scientific revolution was underway. The Islamic Golden Age witnessed a flourishing of intellectual curiosity and scientific exploration. Scholars from diverse backgrounds converged in bustling centers of learning. They built upon the wisdom of ancient civilizations, translating texts and adding their own groundbreaking observations. Let us embark on a journey through time to rediscover the forgotten pioneers who illuminated the path for generations of scientists to come. Our journey begins with Jabir ibn Hayyan, often known in the West as Geber. Born in the 8th century, Jabir was a chemist, alchemist, astronomer, and a pioneer in mineralogy. His meticulous observations and experiments laid the groundwork for modern chemistry and the study of minerals. Jabir's genius lay in his systematic approach to understanding the natural world. He meticulously documented the physical characteristics of minerals, noting their color, hardness, density, and reactions to heat. He developed new techniques for distillation, crystallization, and purification. His crowning achievement in mineralogy was the synthesis of cinnabar from mercury and sulfur. Jabir's pioneering work established him as a towering figure in the history of science. Jabir's systematic approach to mineralogy laid the groundwork for future scholars. One such scholar was Muhammad ibn Zakaria al-Razi, known in the West as Raziz. Al-Razi expanded upon Jabir's work, delving deeper into the properties and classification of minerals. He authored the Book of Stones, categorizing minerals based on their physical and chemical characteristics. He recognized that minerals held clues to the Earth's history and composition. Al-Razi's work laid a crucial foundation for the development of geology and petrology. His keen eye for detail allowed him to distinguish between different types of minerals. Al-Razi's fascination with minerals extended to the rocks they formed. He understood that rocks were constantly being formed, transformed, and destroyed through geological processes. He observed that sedimentary rocks often contained fossils, providing a glimpse into past ecosystems. He theorized that sediments were transported by water and wind, deposited in layers, and gradually compacted to form solid rock. Al-Razi grappled with the concept of geological time, recognizing that Earth's processes operated over vast stretches of time. His writings reveal a mind grappling with the immensity of geological time and the forces that have shaped our planet. Al-Razi's work laid the groundwork for the development of geology and petrology. From the intricate structures of minerals and rocks, we shift our focus to the grand scale of Earth itself. At the forefront of this geographical revolution was Muhammad ibn Musa al-Khwarizmi. Al-Khwarizmi flourished in the vibrant intellectual hub of Baghdad, where he served in the House of Wisdom. He led a team of geographers and astronomers to create the most accurate map of the world known at that time. Al-Khwarizmi's map was a testament to the collaborative spirit of Islamic scholarship. He participated in a project to measure the length of a degree of latitude, calculating the Earth's circumference. Al-Khwarizmi's legacy as a geographer and mathematician is undeniable. While Al-Khuwarizmi was mapping the world, Abu Rayhan al-Biruni was exploring the Earth's mysteries. Al-Biruni was a scholar of encyclopedic knowledge, a true Renaissance man. He wrote extensively about minerals and gems, meticulously describing their properties and origins. Al-Biruni studied the formation of mountains, recognizing that they were formed through the uplift and folding of rock layers. He theorized that the Earth must be immensely old, far older than the few thousand years suggested by religious texts. Al-Bayrouny's insights into Earth's processes were remarkably prescient. His work foreshadowed the development of modern geology and the concept of deep time. The contributions of Al-Khuwarizmi and Al-Bayrouny represent a pivotal chapter in the history of Earth sciences. Their maps, treatises and theories laid the foundation for modern geology, geodesy and mineralogy. The Islamic Golden Age created a fertile ground for scientific inquiry to flourish. Their legacy is etched in the stones they studied and in the foundations of modern science. As we continue to explore our planet, we stand on the shoulders of these scientific giants. Our journey now takes us deeper into the realm of geophysics. Early Muslim scholars laid the groundwork for our understanding of Earth's inner workings. Imam Jafar al-Sadiq recognized that Earth was a dynamic system shaped by forces beneath its surface. He wrote about the concept of Earth's layers, speculating about a molten core surrounded by a solid mantle and crust. Al-Sadiq's observations led him to believe that there were underlying forces at play. His legacy highlights the interconnectedness of knowledge and the importance of seeking understanding through observation and reason. Imam Ja'far al-Sadiq's contributions to geophysics extended beyond his recognition of Earth's internal structure. He was particularly interested in the dynamic processes that shaped the planet's surface. He observed that mountains were slowly being worn down by wind and water. He noted the deposition of sediments in valleys, remnants of eroded mountains. Al-Sadiq was also intrigued by earthquakes, recognizing they were concentrated in certain regions. He speculated that earthquakes were caused by movements deep within the Earth. Al-Sadiq's teachings emphasized observation and deduction in understanding the natural world. Section 3. The Practical Applications of Geophysics. While Imam Ja'far al-Sadiq's contributions were theoretical, other scholars focused on practical applications. They recognized the benefits of understanding Earth's properties, from finding water to predicting earthquakes. In hydrology, they developed techniques for finding groundwater. This was essential for survival in arid regions. They understood aquifers and identified well locations based on surface features. This knowledge was crucial for agriculture and civilization. They also studied minerals, recognizing their properties could reveal Earth's subsurface. This knowledge was applied to prospecting for valuable minerals. Techniques were developed for identifying mining areas based on indicator minerals. This practical application of geophysics showed the link between scientific inquiry and societal needs. Section 1. The Cycle of Life, Water in the Islamic Golden Age. Early Muslim scholars recognized water's profound importance in shaping Earth's environment and sustaining life. They understood the water cycle, observing its continuous motion from evaporation to precipitation. This knowledge led to innovations in water management, like irrigation systems and aqueducts. Their studies also laid the groundwork for meteorology, observing weather patterns and atmospheric processes. The holistic approach to understanding water during the Islamic Golden Age was truly remarkable. Section 2, Ikhwan al-Safa, Unveiling the Secrets of the Skies. The Ikhwan al-Safa, or the Brethren of Purity, were influential scholars during the Islamic Golden Age. They produced the Epistles of the Brethren of Purity, a vast encyclopedia of knowledge. This work reflected their belief in the interconnectedness of all knowledge. They devoted considerable attention to the study of Earth and its atmosphere. They described the water cycle in detail, recognizing its importance for life on Earth. Their insights into these processes demonstrated a remarkable understanding of natural forces. Section 3. Beyond the Clouds, Predicting the Weather. The study of hydrology and meteorology during the Islamic Golden Age was not merely an academic pursuit. Scholars recognized the practical implications of understanding weather patterns, particularly for agriculture and navigation. Farmers relied on the knowledge of seasons and rainfall to plan their crops, while sailors depended on their understanding of winds and currents. Scholars developed methods for observing and predicting the weather. They used astronomical observations, animal behavior, and atmospheric conditions. They documented their observations in meticulous detail, looking for patterns and correlations. One tool was the astrolabe, used to measure the positions of celestial bodies. By observing the sun, moon, and stars, they could predict weather events. These observations were combined with traditional knowledge about seasons and weather patterns. Another method relied on the observation of animal behavior. Birds flying low often indicated rain, while restless livestock signaled a storm. This traditional knowledge provided valuable insights into atmospheric conditions. These early methods reflect a keen awareness of the natural world. The legacy of these early meteorologists lives on in the sophisticated tools we use today. Whispers of ancient life. Our journey through early Muslim scholars' contributions to earth sciences takes us back to a time long before humans walked the earth, when strange and wondrous creatures roamed primeval landscapes. These scholars were intrigued by fossilized remains, recognizing them as clues to Earth's distant past. They sought rational explanations for these enigmatic objects. Their observations laid the groundwork for our understanding of life's journey on Earth. Section 2. Al-Bayrouny, Deciphering Earth's Archives. Abu Rayhan Al-Bayrouny was a keen observer of fossils. His insights into mountain formation and Earth's age were ahead of his time. He noted fossils in specific rock layers. Different layers had distinct fossils like marine shells or plant remains. Some layers even had land animal bones. This showed Earth's history as a tapestry of changing environments. Marine fossils in mountains suggested ancient oceans once covered these areas. Al-Bayrouny connected these observations to envision Earth's dynamic past. His work paved the way for future scientists to decipher Earth's history. The Islamic Golden Age wasn't just about discoveries, it was a revolutionary approach to knowledge. Scholars engaged with ancient wisdom, refining it through observation and experimentation. This is the essence of the scientific method, rooted in their intellectual tradition. They challenged superstition and dogma. They meticulously observed nature, identified patterns, and tested hypotheses. Their empirical approach documented minerals, mapped stars, and described geology. Al-Bayrouny's work on Earth's age and mountains was based on meticulous observations. Institutions like the House of Wisdom were hubs of intellectual exchange, fueling the scientific method. The pursuit of knowledge is often aided by the tools we create. Early Muslim scholars were ingenious inventors. They needed instruments to extend their senses and enhance their analytical capabilities. Their groundbreaking innovations revolutionized fields like astronomy, navigation, and timekeeping. The astrolabe epitomized their ingenuity, a marvel of engineering. It allowed them to determine time, the position of celestial bodies, and the direction of Mecca. Navigators used it to chart courses, while astronomers measured stars and planets. Another revolutionary invention was the magnetic compass. Muslim scholars pioneered its use in navigation. This technology was crucial for exploration and trade routes. The inventions of the Islamic Golden Age were testaments to a mindset that valued observation and experimentation. These tools empowered scholars to unravel the mysteries of Earth and its place in the universe. As we conclude our journey through the remarkable contributions of early Muslim scholars to earth sciences, we're left with a profound sense of awe and inspiration. These pioneers, driven by an insatiable thirst for knowledge and a deep reverence for the natural world, illuminated the path for generations of scientists to come. They didn't simply inherit knowledge, they actively created it, transforming our understanding of minerals and mountains, of water cycles and ancient life. Their legacy, however, has often been obscured, lost in the mists of time and the often Eurocentric narratives of scientific progress. Yet, as we've seen, the contributions of these scholars from the Islamic Golden Age are undeniable, woven into the very fabric of modern earth sciences. From the classification of minerals to the mapping of the stars, from the understanding of Earth's internal structure to the intricate workings of the water cycle, their insights and innovations laid the foundation for our modern scientific endeavors. Their story is a testament to the interconnectedness of knowledge, a reminder that the pursuit of understanding transcends cultural and geographical boundaries. The Islamic Golden Age, with its emphasis on observation, experimentation, and rigorous analysis, planted the seeds for the scientific revolution that would later blossom across the globe. The impact of these early Muslim scholars extends far beyond their individual discoveries. They instilled a spirit of inquiry, a passion for unraveling the mysteries of the natural world that continues to inspire us today. Their meticulous observations, their ingenious inventions, and their groundbreaking theories remind us that science is a cumulative endeavor built on the foundations laid by those who came before us. As we face the challenges of a rapidly changing planet, from climate change to resource depletion, we can draw inspiration from the legacy of these scientific pioneers. Their holistic approach to knowledge, their understanding of the interconnectedness of Earth systems, and their commitment to observation and analysis provide a valuable roadmap for navigating the complexities of our planet's future. Their story is a call to action, a reminder that the pursuit of knowledge is not a passive endeavor but an active engagement with the world around us. It's a call to embrace curiosity, to challenge assumptions, and to never stop asking questions about the natural world. As we continue to explore our planet, from the highest mountains to the deepest oceans, let us carry with us the spirit of these forgotten pioneers, their legacy a beacon guiding us toward a deeper understanding of Earth and our place within its intricate web of life.